So good day, Sir Adlin, and tangal greetings to you. And this is my lab activity for the midterms. First lab activity for midterms. So here we have this program that I have assembled for the activity 1, which is this. So it says here that write an assembly program to add the following data and then use the simulator to examine the C, H, Z, and Z flags after the execution of each addition. So here I have solved the problem handwritten. So you can see it here. So let's proceed. Let's reset. Reset the values. So okay. LDI, we load the immediate values to the corresponding registers of R20 and R21. Here we go. There we go. And then the flag that it will raise is S and N, but it did not raise the carry flag, the H flag, and the 0 flag because this is the explanation. 0x92, this is the equivalent binary digit. 0x93, this is the equivalent binary digit, and when we add the two of them, as you can see, there is no carry outside because 1 plus 0 is 1, so there is no carry. In the half carry, on the lower table and the upper table, there is no carry. 0 plus 0 is 0, 1 plus 1, 0 is 1. So there is no carry on the half carry. And as you can see, it is not 0 because it has a value. So the 0 flag is also not raised. So next, we will load another immediate value, 0x66. And then let's see the flags that it will raise. As you can see, it raised the carry flag. So here is the explanation. So the resulting value earlier, we will add it to the value of 0x66. And the binary equivalent of 0x66 is this. So 1 plus 1, and as you can see here, it has a carry because 1 plus 1 is 0. Carry 1 and 1 plus 1 is 0. Carry 1. So the carry flag was raised. So the third one here, we load the immediate value of 87, 0x87, or hexadecimal 87, and then voila, we have the half carry signal that is carried, or that is, we have the half carry flag that is raised. So this is the binary digit for 87 hexadecimal. So we add it to the resulting earlier, and this is the nibble. The lower nibble and the upper nibble, this is the nibble in between. So 1 plus 1 is 0, carry 1, and as you can see, between the lower nibble and the upper nibble, it raised a carry. So there is a half carry flag. And that is the reason why it is raised. So on the last one, we have F5, and then we will add it. As you can see, it raised the carry flag. So here, you can see, this is the binary equivalent of F5. And then here you can see that 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry here, so there is a carry already, and then plus 1, so this is 1. But there is a carry already here, so the carry flag was raised. So that is all for the activity 1. So let's go to activity 2. So activity 2, where is activity 2? Here is activity 2. So let's load it. Okay, let's debug it. So activity 2, it says here, write and assemble the following program as a simulator to examine the flag. So we will use this watch panel here to appreciate it more. Okay, so because we will need to convert hexadecimal to decimal to further understand what this means. So let's go to the first step. We load immediate values to the registers. There we go, and then we subtract it. 39 minus 21, we will have 18. Then this is a decimal value, huh? And when you convert this 18 to hexadecimal, you will have 0x12, which is right here, R20. And then here, you can see that there is no flag raised. Okay, so on the next step, we will load again, load immediate values to the registers, and we will subtract 32 minus 21, we will have 11. And when we convert this 11 to hexadecimal, you will have 0x0b, that is b, okay? And there is a half carry flag, as you can see, because between the upper nibble and the lower nibble, as I've said earlier, there has been a carry between. So there is a half carry flag that is raised in the second one. So if we proceed further, we will load again in the R24 and R25, but these are decimal values, 95 and 95. So we will load it. There you go, 95, and there you go, 95. As you can see here, in hexadecimal, that is 5F and 5F. So when you subtract the two of that, 95 minus 95 is 0. So the 0 flag was raised because 95 minus 95 is 0. So hence the 0 flag. And in the last one, we load the immediate values to R22 and R23. And then we subtract it. Okay. So we have 50 and 70. No? And when we subtract the two of that, we will have carry. Carry, because 50 and 70, this 50 here is lesser than 70, so there has been a carry. And as you can see here, there is also a half carry flag because in between there has been also a carry. Yeah, as you can see there. So yeah, that's it. But as you can see, the answer was not 0, so hence not the 0 flag. The 0 flag was not raised. So on the third one, let's go to the third one. It says here that a third activity that explain also, but use the COM instruction. So let's build this for a second. There you go. Okay. Okay, let's minimize this. Let's focus here. There you go. So we debug it and then we go to the step-by-step procedures. And then let's watch. Okay. So here, LDI. So we load the immediate values to the corresponding registers. R20. There you go, there you go, there you go, there you go. So here, the COM instruction simply means that all of the bits, for example, here in 0, that has 00000 bits. So in COM instruction, what you will do is that you will reverse, or you will you will put the opposite value, the opposite binary digit of the given digit. So for example here 000, you will put 11111, and that is equivalent to 255, as you can see here, because if you step, there you go, that is 25555, and here that is FF. Okay, so another one, as you can see here, 0xFF is 1111, so when we COM instruct that 0000, and that will result to 0. Okay, and then another one, 0x11 001. Okay, and when we COM instruct that 238 in decimal, there you go, and EE in hexadecimal, which you can see right here. And then another one, 221. So there you go, 221, and DD. Here you go, DD. So that's how the COM instruction works, no? So let's go to the last one. I know this has been more than 10 minutes already, so let's go to the last one already. And let's build this. Okay. Here it said find the value of the C plug. Okay, find the value of the C plug. So this is the first one. Wait, I will fix it first. There you go. And then let's build that. There you go. Let's build it. And then let's debug it. Okay. So here I have also solved this in a paper. So let's step, load immediate values to the register, and then let's add. As you can see, the carry flag has been raised. This is the explanation. 85 and 92, these are the binary corresponding digits. And when you look at the most significant bit, 1 plus 1 is 0, carry 1, and that is the reason why there is a carry flag that was raised. Okay? So on the next one, let's copy this and let's paste. There you go, and let's build it. There you go. Okay, so let's debug. There it goes. Here, see here. When we step this, load immediate values, okay, and then we add it, we will notice that the carry flag was not raised. The reason for that is here, 15 and then 72, these are the binary digits that corresponds to them. So as you can see, 0 plus 0 is, or actually there is a raise here. So 1 plus 1 is 0, carry 1, and 1 plus 0 is 1. Hence, there is no carries, and the carry flag was not raised. Okay? That is the reason why there is no carry here. So, next one, we have LD, I, which is an C. So, let's fix this for a second. Okay, let's build that. And let's debug that. There you go. And then we have this. There you go. Here in C, let's load the immediate values to the registers. Okay, here you can see that the C flag has been raised. Okay, the reason for that is this. The values of F5 and 52 is this, the binary. And as you can see here, there is a raising. So 1 plus 1 plus 0 is 0, carry 1, 1 plus 1, then carry 1 here. So 1 plus 1, carry 1 here, plus 1 is 1, but there is a carry 1 here already, so 1 plus 1 is 0, carry 1. So hence, the carry flag is raised. So that's just how it goes. And then here, we will have the last one, which is the increment. There we go, so let's build it. There we go. Okay, so let's increment, alright? There you go, we have debugged it. So, step, let's load the immediate values. And as you can see, we will increment it by 1. So that is 255. And as you can see here, it matches with my solution. It is 1111, which is 2555 or FF. So when you step another one, it will be 0. Okay, but the 0 flag has been raised, right? And there should be a carry flag here since 1, okay, and then there will be a carry on the end. But here there is no carries, which is, I don't know why, but it is 0. But hence, this is just the solution, so it's not really the basis. But I think there should be a carry here at the end. Well, I guess that's the end of it. So, sir, that's everything for my laboratory. And I know this has been too long already, so I will not take most of your time now. So, I hope you learned something today, and I hope I answered all of the questions correctly in the laboratory. Thank you, sir, for listening.